Okay, so the next thing that we have here is an exercise that basically says you have a parabola over here, and the parabola is y squared is equal to 8x, and you want to find these basically characteristics of this parabola, meaning that you want to find the coordinates of the focus, the coordinates of the focus. You want to find the axis. You want to find the equation of the directrix, and you want to find the latus rectum of this parabola. So basically we said that the parabola can have 4 different types of equations, or actually 2 types. If you do not differentiate between the negative and positive, you could have y squared is equal to 4ax and x squared is equal to 4ay. And of course here you would get basically 2 different variations. Y squared is equal to and I suppose I said something in so if and I did say something in the previous video which, now that I think about it, is actually not right. I wanted to basically, we were talking about something about the value of a over here, or I'm sorry, the value of x over here, and I said that it was right over here if I'm not mistaken. Now in this equation, I see. So if you have, for example, if you have something like y squared is equal to 4ax, so over here a is greater than 0. So since a is greater than 0, then of course y squared has to be in a positive value. So then x can take only positive values, and that's basically why your parabola starts from here essentially and goes the other way on the positive axis. So since a is greater than 0, so then x has to be greater than or equal to 0. But on the other hand, now this is I'm just making some corrections on what I said in the previous video. Now on the other hand, if you have y squared is equal to negative 4ax, now still y squared has to be has to be a positive value. So over here a is less than 0. It's a negative value. So since it's a negative value, then automatically meaning that what that means is that basically a is basically of course a positive value, but then of course then negative a, if a is a positive value, then negative a is going to be a negative value. And since negative a is a negative value, you have to multiply. Of course 4 cannot be positive, 4 cannot be negative. So then x has to be a negative value so that the overall value over here becomes positive. And that's basically why this kind of parabola goes the other way around, meaning that it goes in this direction, meaning that you can have only negative x's over here. That's basically the mistake that I made, or probably I didn't explain this properly, because I didn't realize it myself then. And now that I think about it, it's basically the reason why basically your parabola goes to the left or goes to the right, goes to the top or goes to the bottom. So that's one thing over here. Now if you have this parabola, so basically we had 4 different equations for these parabolas. We said that either y squared is equal to 4ax, or y squared is equal to negative 4ax, or x squared is equal to 4ay, or x squared is equal to negative 4ay. Which means that now what we have over here is basically fits with this one. So I can use this equation as the standard form and general way of describing this parabola. So then y squared is equal to 4 times ax is going to be the general or the standard equation of this parabola. And again, since you know that basically a is always a positive value in all of these parabolas, so then since again y squared has to be a positive value, then x can only be a positive value, it cannot be negative. Then the shape of your parabola is going to be something like this. You can have only positive x's. And so what that means is that your focus is going to be some point over here, a comma 0. Your directrix is going to be over here, basically x is equal to negative a, and that's basically all that we have here. And we said that basically the lattice rectum of this parabola, the lattice rectum is equal to 4a. And what else do we need? We need the coordinates of the focus is basically this. The axis is the axis, which is the x-axis, or the line basically y is equal to 0. This line over here. The equation of the directrix is this, and the lattice rectum is basically this thing over here. So based on this, you can, based on the information that you have, you can find basically the value of a over here, and then you can find, based on that, you can find all the other values here. And so in order to find what my a is, I have to write this as basically 4 times 2 times x. So if I write this equation as y squared is equal to 4 times 2 times x, then if I basically compare these two equations, then that means that my a is equal to 2. Now if my a is equal to 2, then the equation of the lattice rectum, the equation of the directrix, the equation of the directrix becomes x is equal to negative 2. The coordinates of the focus becomes basically a is equal to 2 and 2, 0. And the length of the lattice rectum is equal to 4 times a, which is equal to 4 times 2 is equal to 8 units. So So now if you actually drew this parabola down here, what you would get is that if y squared is equal to 4 is equal to this, where is that parabola? Y squared is equal to 8x. If y is equal to 8x, if you want to draw the graph of this parabola, is that basically what you can do is that, of course, you can have your coordinate axes, y-axis and the x-axis, and then you can have a table of values, and basically the table of values, what you can do, you can have your x and y over here, and so for example, if I set x is equal to 1, then I will get y squared is equal to 8, which is not very convenient here, meaning that I have, for example, y squared is equal to 8x, for example. If I set x is equal to 1, then then this equation becomes y squared is equal to this equation becomes y squared is equal to 8 times 1, which is equal to 8. Now then y becomes plus or minus the square root of 8, which is, for example, plus or minus 2 square root of 2, for example. That way you can do it. Or you can start with the values of y, not with x, because you have because your equation is primarily y squared is equal to 8x. You have the second power of y. So I said, for example, y is equal to 1, and then I will get basically, for example, 1 squared is equal to 8x. That means that 1 is equal to 8x. That means that x is equal to 1/8, for example. So that means that if y is equal to 1, x is equal to 1/8. If x is equal to 1/8, if y is equal to 1, for example, your x is going to be equal to 1/8. Now if, for example, y is equal to 2, what happens is that 2 squared is equal to 8x. That means that 4 is equal to 8x. That means that x is equal to 1/2. Is equal to 1/2. So if y is equal to 2, then your x is equal to 1/2. If y is equal to 0, then basically 0 squared is equal to 8x. That means that x is equal to 0. If y is equal to -1, again you will get -1 squared is equal to 8x, and then basically -1 squared is equal to 8x, and that means that 1 is equal to 8x, and that means that x is equal to 1/8. So there you get 1/8 over here, and -2, again you will get 1/2, positive 1/2. And so that way you can basically enter these values, plot these values. 0, 0 would be 1 point, and then we have, for example, x is equal to 1/8, y is equal to 1. So x is equal to 1, it's 1 is equal to 1, so that is 1/2, that is 1/4, and that is 1/8 over here. 1/8, 1 is this point over here. 1/2, 2 would be this point over here, and then 1/8, -1 would be this point and this point over here, and you would have this parabola like this. Of course, there is all kinds of information that you can it's all about the transformations of these parabolas and everything that we are going to discuss, I suppose, probably in the next book, not here. But well, everything step by step. Now you see that over here, if I set a is equal to 2, meaning that as we calculated here, the focus is 2 comma 0. So 2 comma 0 is your focus, is the point of focus. And in order to see basically my lattice rectum here, I need to know what exactly the value of y here is at x is equal to 2. So then basically y squared is equal to 8x, and at x is equal to 2, so y squared is equal to 8 times 2, and y squared is equal to 16. So y is equal to plus or minus square root of 16, which is equal to plus or minus 2 times 4, which is equal to plus or minus 2 times the square root of 2. 2 times the square root of 2. Now 2 times the square root of 2 is something about 2.8. Is something about 2.8. 2 times square root of 2 is equal to 2.8. So that means that at x is equal to 2, your y is 2 square root of 2, meaning that 2.8 over here, somewhere over here, and negative 2.8, which is somewhere over here. Which is somewhere over here. So then what that means is that this point over here is basically x is equal to 2 and y is equal to 2 square root of 2. And this point over here is x is equal to 2 negative 2 square root of 2. This point and this point. Now what that means is that this distance over here is 2 square root of 2. So your lattice rectum is practically basically this distance over here. Right? So this is your lattice rectum. So your lattice rectum is equal to basically the distance from here to here is 2 square root of 2. So 2 times basically 2 times 2 square root of 2 is equal to this is 4, 16, 32. I do not understand why units. Maybe I have made a mistake over here. Y squared is equal to 8x at x is equal to 2. 8 times 2 is equal to 16. Y squared, oh that is, yes, I have made a mistake over here actually. 16. So that is actually plus or minus 16, which is actually y is equal to plus or minus 4. So you have to go all the way up to 4, not here. I apologize for this mistake. So then 1, 2, 3, and 4 would be this point over here, and 1, 2, 3, and 4. 1, 2, 3, and 4 would be this point over here. So that means that basically your parabola actually opens like this. Actually opens like this, and so these 2 points, and so this is your lattice rectum. This is your lattice rectum, and this point over here is basically 2 comma 4, and this point over here is 2 comma negative 4. Is 2 comma negative 4. And so as you can see, the length of this line is 4 units here and 4 units here, which is basically 8 units over here. And the length and the length of your the equation of your directrix is x is equal to -2. So x is equal to -2 would be this point over here, and that would be this line would be your directrix. X is equal to -2. That is your directrix. Now, since this is your directrix, any point that I take over here, for example, let's say that I take this point over here, this point, this distance over here, which is the distance of the point to your focus, has to be equal to this distance over here, which is basically the perpendicular distance to your directrix. And as you can see, this is 4 units, and this is exactly 4 units over here. And so that is actually basically the definition of a parabola. And you can basically you can pick any other points. For example, this point over here, you can find, let me do it in another color. This point over here, find you see on the software down here, when I want to draw the line, it gives me some distance, 167 pixels. Okay, and this distance over here is 200 pixels, but they're supposed to be the same, meaning that probably my units and everything are not really well drawn, but they're supposed to be the same distance. And of course, you can calculate any point on. Let me go back over here. Let me calculate the particular point. Let me calculate a particular point on this parabola. For example, we said that basically at x is equal to 1/2. This point over here was 1/2, 2. This point was 1/2, 2. Write it properly. This point over here is basically, I'm sorry, not that point, but this point over here is supposed to be 1/2, 2. That we did calculate. 1/2, 2. And if I draw a line over here to the focus and a perpendicular to the directrix, so I have basically these 2 points over here, meaning that I have this point, call it, for example, C, F, and B. C, F, and F, C, and B. Now, CF is supposed to be equal to BC. Now, CF over here, CF, I can use the distance formula to find the distance between these 2 points. And that is basically 1/2 minus 2. 1/2 minus 2 whole squared plus 2 minus 0 whole squared, which is equal to basically 1/2 minus 2 is equal to 1 and 1/2. That is 3/2. 1/2 minus 2 is equal to 2. 1 minus 4, that's negative 3/2. Negative 3/2. Negative 3/2 whole squared plus 2 squared and then you have basically the square root of 9/4 plus 4, and that is the square root of 4 over here, 9 plus 16, that's 25/4, the square root of 25/4, which is equal to 5/2. So your CF is equal to 5/2 units. Your CF is equal to 5/2 units. Now BC over here, you want to find the distance between point C and this line over here. So the line is basically x is equal to -2, and your point is 1/2, 2. You can use, since the distance is the perpendicular distance, you do need to use the formula D is equal to the absolute value of ax1 plus by1, as we had before, plus c, over the square root of a squared plus b squared. And so if I write this line as, basically I can write this line as, I can write it as basically ax plus by plus c is equal to 0, and that would be basically x plus 2 is equal to 0. So that means that your a is equal to 1, your b is equal to 0, your c is equal to 2. A is equal to 1, your b is equal to 0, your c is equal to 2. That is the values that you need to put here. Because your y is simply not there, it's absent. It means that the coefficient is 0, and your c is positive 2. And x1, y1 are basically these 2 points. So your d is equal to basically the absolute value of a times x1, which is 1/2, plus by1, which is 0, plus c, which is basically 2, plus 2, over the square root of a squared plus b squared, which is the square root of b squared is 0, and that is 1. So you have the absolute value of 2 and 1/2, which is 2 1/2, which is 3, which is 5/2, which is the absolute value of basically 1/2 again, plus 2 is equal to 2, 1 plus 4 is equal to 5/2. So the absolute value of 5/2 over the square root of 1, which is equal to 5/2. So that means that basically this distance over here, which was basically BC, is equal to, again, 5/2 units. And that basically that is basically why we say that it is this conic section is a parabola, because any point that you pick here, the distance of that point from the focus, and the distance of the same point to the perpendicular distance of the same point to the directrix is basically essentially the same values. So we found everything that we needed over here. We did a little bit of experimentation here as well, and that's basically the answer. Now we have a couple more questions, essentially 3 more questions that we will do in this video as well, and then we have some exercises. Okay, so the next question that we have is, you want to find the equation of the parabola. You want to find the equation of the parabola with focus 2, 0 and directrix and directrix x is equal to -2. So your directrix is at x is equal to -2, and it is exactly what we had. It is this parabola is exactly the parabola that we had over here, 2, 0, and directrix is at x is equal to -2. But now, in order to find out what this is, basically you know that if you have a parabola where, I mean, the way that I can understand this is that if you have a parabola that basically, suppose that this is your x and y axis, and if your directrix is over here, x is equal to -2. Let me write it this way. If x is equal to -2 is the directrix, then of course you know that the equation of the and then if the directrix is over here, of course naturally the parabola is going to be somewhere over here. So we saw this before, and we found what we found was that basically the focus of this parabola, the point which was called the focus of the parabola was at a, 0, and the directrix was at x is equal to -a. So now you have x is equal to -2 and x is equal to -a. That means that -2 is equal to -a. That means that a is equal to 2. So if your a is equal to 2, that means that your focus is basically over here. That is your focus, which is you can call it f, and the coordinates of this is basically 2, 0, or basically a, 0. So now, since this is the point, this is the information that we have about this parabola. We said that the equation of this parabola was y squared is equal to 4 times ax. So that means that y squared is equal to 4 times a is equal to 2 times x. That means that y squared is equal to 8x. That is the equation of your parabola. So if you basically understand the situation, you will be able to use one of these equations as basically y squared is equal to 4ax, or y squared is equal to -4ax, or x squared is equal to 4ay, or x squared is equal to -4ay, and then using any of these 4 equations, write the equation of your parabola. Or let's suppose that, for example, as another example, let's suppose that you want the parabola with vertex at 0, 0, and the focus is at 0, 2, and you want to find the equation. So of course all of those parabolas that we had, their vertex were at 0, 0, so that's not something that I can really use. I mean, all of those 4 equations that we had, in all of those 4 cases the vertex was at 0, 0, so this is not really an important fact over here. The important here is that the focus is at 0, 2. 0, 2 means that basically your focus is over here. Your focus is over here, 0, 2. If your focus is here, that means that your parabola basically goes upwards, and your directrix is somewhere over here. So basically -1, -2. y is equal to -2. And the reason why I'm saying this is that because we had basically this case where your parabola was opening upwards, and your focus was at basically 0 comma a, 0 was at 0 comma a, and then your directrix was the line x or y is equal to -a, and the equation of this parabola was x squared is equal to positive 4 times ax, 4 times ay. So we had this situation here, and since my focus is right here, so it just fits this situation, so I can simply use this equation. And basically when the point is at 0 comma 2, that tells me that my a is equal to +2. So if my a is equal to +2, then I can write x squared is equal to 4 times 2 times y. So that means that x squared is equal to 8y. That is, well, simple when you understand those 4 cases. There is nothing complicated about these parabolas. Or suppose that you have, as another example, let's say that you want to find the equation of the parabola which is symmetric about the y-axis. Symmetric about the y-axis, and passes through the point (2, -3). Okay, so my parabola is, and of course I'm in all of these cases, since we have, all that we have done is basically parabolas that basically whose vertex are at the origin. The vertex of the parabola is at the origin, and it opens towards the right, or it opens towards the left, or it opens towards the top, or it opens towards the bottom. So, and we have basically we have derived 4 equations for these four different situations. So that's basically the assumption that I'm making. So what that means is that now we said that the parabola passes through this point 2, -3. 2, -3. So that is the point where 2, -3. Now, if I have a parabola that passes through this point, it could either be this parabola, or it could be this parabola. It could be both of these parabolas. But since they're telling me that it's symmetric about the y-axis, so then of course this cannot be the parabola, because this parabola is symmetric about the x-axis. So this has to be the parabola. So that means that the parabola that I have has to be this parabola. If it's symmetric about the y-axis, then another point on this parabola is going to be -2, -3. So -2, -3 would be here, and then it goes through the origin as well. And these are all assumptions that I'm making. based on the theory that we have read. Otherwise, I'm not, for example, allowed to make this assumption that the parabola necessarily goes through the origin. That's just some assumption that I'm making, and it's a safe assumption here. Otherwise, when you know more about these parabolas, then of course you need to basically use some other information, for example, to know where your vertex is. You cannot just simply make an assumption that the parabola goes through the origin. But here I can do that. So now this is the x-axis and this is the y-axis, and well, all I know that it's symmetric about the y-axis, and it passes through this point. So if the parabola passes through this point, of course, if my parabola is again symmetric about the y-axis, the equation has to be x squared is equal to negative 4ay, negative 4ay, and I don't know what my a is. Basically, I don't know anything about my a. But I know that the parabola that opens downwards and is symmetric about the y-axis, the equation of that parabola is going to be in this form: x squared is equal to negative 4ay. So if that's the case, if I have x squared is equal to negative 4ay, if that is the case, and if the parabola goes through this point 2, negative 3, then I can substitute these x and y's over here, meaning that I can write 2 squared is equal to negative 4 times a times negative 3, meaning that 4 is equal to 12 times 3 times 4 is equal to 12 times a, and a is equal to 4/12, which is equal to 1/3. A is equal to 1/3. So that means that over here a is equal to 1/3. Now if a is equal to 1/3, then of course you can basically substitute this back in this equation, meaning that you can write x squared is equal to negative 4ay, and if a is equal to 1/3, like you can write x squared is equal to negative 4 times 1/3 times basically times y, which is equal to x squared is equal to negative 4/3 y. That is the equation of your parabola. Or they have written this as 3x squared is equal to negative 4y. You can write it this way as well. And of course, you do understand that basically your directrix is at y is equal to 1/3, meaning that if this is 1 unit, then your directrix is going to be this line over here. This is your directrix at y is equal to 1/3. So that is basically that. So now we are done with the theory part and the examples that we had related to these parabolas. The next thing that we have is a couple of exercises. 275. A couple of exercises, only 12 of them, that we will do in the next video. See you in the next video.